Hi and welcome to an overview of the latest features shipping with the exciting first beta version of 3DEqualizer4 Release 6. This release is packed with new functions and scripts, so we picked the best ones to demo them. Alright, let's start right away with updates to the 3DE4 UI. Release 6 was downloaded from 3DEqualizer.com and is waiting for us. So let's start with our good old sequence STA. By the way, this sequence is downloadable from section Download on 3DEqualizer.com. Let's start with the most obvious change to the UI, point colors. In Object Browser, the defined point color is now displayed right beside the point name. The point color seen here is equal to the point's 2D color. This was a popular request by many users who use different point colors within the project. For example, one for survey-free and another one for surveyed points, or maybe depicting groups like one color for tables, one for walls, and so on. Changing the color can be done in Attribute Editor via its attribute color, or via a point's context menu in Point Browser. Next is sorting 3D models. Now it's possible to sort 3D models as you like by simply middle-clicking the item and drag it to its new position. A minor but very useful upgrade. Alright, let's move on to updated Python panes. Since Release 5, it's possible to add Python scripts as panes by adding a single line of code within the script. In Release 6, the pane's visibility was addressed by automatically adding a scroll bar to the pane if its content exceeds the pane's height. One more reason to use this useful feature. But not all widgets are designed for this feature. In script transform to poses, for example, all widgets react to window size and change accordingly. Therefore, it basically never happens that they exceed the window size, although they can become very small. So, it's time to talk a bit about an old feature, the overlay grid. This feature kind of flies under the radar, but nevertheless it's very useful and of course worth updating as well. What is it for? Let's say we have a 2D point that cannot be tracked in every frame, but is crucial for a good solve in case we don't have much other data. Best thing to do is guess the point's 2D curve as precisely as possible to help 3DE4 solving the shot. In order to do that, we look for a visible feature nearby, which we can use as a reference. Of course, features around the same z-depth are great to minimize parallax effects and make them reliable reference objects. In our case, let's try the ladder. Specifically, right ladder stringer and bottom rung seem to fit very well. At first, it would be nice to snap the grid to the 2D point so all lines are always static around it. Back in the menu, with all these options here we can modify the grid size and rotation until one line of the grid matches with the ladder. In Release 6 Beta 1, rotating was added to the grid, making it even more helpful than before. As usual, it's always worth working with shortcuts to improve working speed. Looks great, we have a good reference. Now we know the distance and orientation of marker and ladder, and can assume that it must be the same within the frames of chair hiding the marker. Okay, so go forward some frames and place the 2D point. Check both keyframes. Yeah, looking good. In this example, it would be perfectly fine to spline the frames before and after. So, have a quick look at the result. Nice. To sum up all options for overlay grid, a color can be set as well to be able to respond to all kinds of colors or brightness in the footage. That's overlay grid. Give it a try next time if more tracking data is needed. In Release 6 Beta 1, FOV crop masks were added. In case a shot has different crop sizes, now it's possible to display that. So, let's set a new mask. Assuming here crop size is simply 20% smaller than the footage. Alright, to display it, activate View, Show FOV Crop Mask. Of course, FOV crop masks can be activated in F1 overview controls, as well as F5 lineup controls. Next is a popular feature request as well, extracting vertices, lines and also polygons directly in F6 3D orientation controls. The same beloved features from lineup controls are now available there as well. With uprising sophisticated LiDAR scans and geomodels with embedded textures, creating survey in F6 is way easier than before. Here we have such a textured 3D model created entirely within 3D4 with its refined polygon feature. By the way, there's a great tutorial about recreating a set from reference frames on 3DEqualizer4.com called Set Reconstruction. Back to the topic. So let's say this 3D model is a scan from set, so there's survey data available. Assigning a 2D tracking point to its correct surveyed position is now incredibly easy. Just exactly like in lineup controls, with a point selected, we can assign it to a vertex, a line, and polygon of a 3D model. Extracting 3D data directly in 3D orientation controls is an immensely useful feature and will put a smile on users' faces around the globe. Enough smiling, this is serious here. On to the next feature. Enhanced visibility and parameter adjustment window. Previously, all parameter values resulting in a deviation above 10 pixels were clipped due to the simple fact that these results can hardly be used for delivering shots. However, projects are becoming more and more complicated and might have very high initial deviations. One awesome feature of parameter adjustment window is its depiction of the adjustment progress. The point cloud tells a lot if the adjustment is on the right track, or if there might be the need for additional adjustments, if lowest point is at the edge of a point cloud, just to mention two. To be able to use these troubleshooting features in a project with high deviations as well, button Show All disables the clipping and all points of the point cloud are visible. (2D tracking tools got an exciting update. Align points to reference pattern. This new tool is a great extension to the Align to Keyframe script. It aligns the currently selected point to a keyframe set in the same or, and now it's getting cool, any other camera, sequence or reference. Add this script as pane. Then select a point with some keyframes. Here we see a big list widget containing all keyframes this point has across all available cameras. Obviously only in camera SDA, so far. By the way, this list is being updated immediately when a point is selected. The big advantage of this new script is it allows us to select a very specific keyframe as reference pattern. Should the feature's orientation to the camera change within the shot and deforming a feature's appearance on 2D footage, some keyframes are more suitable for being a reference than others, for being precisely found in the other camera. In said other camera, this pattern is quite perpendicular to the camera, so we use a keyframe that is as similar as possible from camera STA. Like these towards the end of the shot. Alright, place the point anywhere near the feature we tracked in camera STA, select the keyframe, and click Align to Ref Pattern. And here we go, perfectly tracked in this frame. From here, it's now easy to continue tracking. The next feature will make friends of stereoscopic tracking quite happy. Well, maybe even more the data wranglers. Let's import a SXR sequence to show what's new. Alright, a quick look at the shot. Nice shot of a DeLorean. Having a SXR file imported, a file type which contains both eyes, left and right, it is now possible to set which eye is visible in display area directly in 3D4. In the attribute editor, have a look at attribute SXR import. By default, it's set to left eye, but obviously this can be changed to right eye. Et voila, the right eye is shown. So, to track a stereo sequence, it is no longer needed to convert a SXR into two separate sequences, which uses a lot of space on servers. The same file can be used with two cameras, one set to left eye and one to right eye. As mentioned, probably especially data wranglers might be happy about this great new feature. The feature train continues in rapid speed. We have no time and so much to show. Next stop is enhanced support for OpenEXR files. A great feature of EXR files are the embedded information about data in display windows. Release 6 Beta 1 now can handle this information, as well via a new attribute in Attribute Editor. Here, with OpenEXR import, it can be defined which window should be imported from the file. Dealing with OBJs can be quite challenging, and over the years 3DE4 introduced many features to improve performance when working even with large files, like reduced import times and performance rendering. Still, it is inevitable that very large OBJ files cause longer import times if they are set as reference, meaning they are not saved within the 3DE file but stored in a different location. This option is very useful if 3DE file size should be kept at a minimum, but at the cost of performance. But sometimes, during specific phases of solving a shot, external files aren't always needed, so these longer waiting times during opening a project can be quite frustrating. To address this, 3DE 6 Beta 1 introduces an option to select if an external OBJ should be imported directly when loading the project file. So, if we open a project containing one or more 3D models set as reference, a new requester appears asking whether the models should be imported or not. If not, 3DE4 displays them as a placeholder in 3D orientation controls, so it can be seen that originally there is a model within the scene. Now, in case we need the model again, of course it's possible to reload it without reopening the project with script reload 3D models, found in the 3D Models context menu. 3DE4 Release 6 Beta 1 introduces a new distortion model, anamorphic rescaled degree 4. Over the time, a problem with rescaled anamorphic footage became more relevant, since more studios intended to optimize the pipeline by excluding the need for setting a pixel aspect, by rescaling the image. As seen in this project, we have the same grid shot. The first one is the original, the second one was rescaled. The first grid is deformed a lot, due to its pixel aspect. So, in its lens, change pixel aspect to 2. Now both grids' appearances are identical again. And we see, due to the original pixel aspect of 2, the rescale image is twice as wide, and works with a default pixel aspect of 1. This rescaling seems a nice idea in the beginning, but unfortunately causes a big conflict with lens distortion. More precisely, calculating distortion parameters if lens rotation is not exactly 0. A quick demo. Start with the original grid shot. Everything's set up, a matrix covering the entire grid is available, and its lens is defined as anamorphic. Let's calculate distortion parameters. The deviation looks good. So let's have a quick check with the undistorted image. Hide matrix, undistort the image. Nice. On to the rescaled grid shot. Should be working fine as well, right? Here we also have a matrix snapped to the checkerboard's corners and an individual lens also set as anamorphic. So again, calculate distortion. Oh lord, this looks semi-nice. Deviation is 10 times higher. What the F happened? As mentioned before, lens rotation has some heavy influence here. Having no lens rotation, it's perfectly fine to rescale an image along all axes. Distortion values have to be adjusted again for rescaled shot, but they still are consistent to each other. This changes drastically if the lens was rotated during shooting, even if it's rotated just slightly. Rescaling footage now results in a non-uniform transformation, more like a skewed image. Therefore, all distortion changes immensely. To correct this, the image basically has to be scaled along the rotated axis. And this is exactly what the new distortion model, anamorphic rescaled degree 4, is taking into account. So, select this new model within the lens. And here we see a new parameter simply called rescale. This parameter defines the scale factor. Basically, it's the original pixel aspect. Since we know it, the correct value here is 2. Alright, back to calculating distortion. Use all parameters selected by default and show me the way to a much better deviation. Looks great. Again, one last visual check with the undistorted image. Now, let's compare both grids. Perfect. This was all about the new distortion model anamorphic rescaled degree 4, which will help tremendously creating a working lens for rescaled anamorphic footage. We're staying in the world of grid shots and welcome a new feature dealing with STMaps. Say hello to script, convert STMaps image file to matrix. The title is pretty obvious. If there's already lens distortion information in form of an STMap file, simply use it to get a correct matrix for this grid shot. Here we can see a nice STMap containing all the information we need. Please note that an undistorted file is needed to apply lens distortion for undistorting footage. Import it, and that's it. The matrix was converted accordingly and fits great. To apply this information on the lens, simply calculate distortion. Set parameters and have a quick visual check. Hide the matrix. Undistort footage. Awesome. Fast and clean. What do we want more? Release 6 Beta 1 introduces a new tool for improving visibility of rendered footage. Foreground masks. Let's say we have a very nice shot, everything solved, which contains some 3D models. As seen in overview controls, the models are overlaying the entire footage, resulting in a little visual mess. Would be better if they are rendered just behind this great guy with his beautiful blue box. In menu view, we can find Render Foreground Mask. When we activate it, all models are now precisely cut out where the guy is standing. Well, more or less precisely. But still, the image can be read much easier than before, having all objects now visually in the right depth. Like in footage, in 3D space the columns are behind the guy in box. So, where is this mask coming from? Very simple, it's an auto-tracking mask. In this demo it was created directly within 3DE4, but it also works with an image sequence, imported via the camera's mask setting in Attribute Editor. Any mask created or imported will be considered when rendering footage in 3DE4 for this camera. Release 6 didn't stop here when it comes to improve render features. Script Save Out Rendered Frames also got a great update. Independently from all UI settings, it is now possible to set render flags. For example, if 3D models should be visible, or motion blur, or the FOV. Regardless of the settings in overview controls, they can be overridden here and also provide a nice check what will be seen in the final render. Over the last years, memory size became a big topic in the industry. Footage now has high resolutions. 8K main cameras, even 4K witness cameras are not that exotic anymore. And we don't start discussing challenging frame rate experiments like 120 frames per second. Of course, studios cannot upgrade every computer if such a show is appearing. So let 3DE4 make our lives a bit easier, with a massively optimization upgrade to buffer compression files. This is a truly great feature. Okay, let's demo this. Import a long shot, like this one, with nearly 3000 frames. Playing this sequence without all frames cached in memory is slow, obviously. So import the already existing image buffer compression file. Yes, importing still takes some time. Depending on the shot's length, maybe practice your table tennis skills. Or ask your head of department how he or she is doing. Sure, they will be delighted. Finished already. Back to business. Having nearly 3000 frames, even as compressed files, already takes over 20% of my memory. That's a lot. Going through the sequence now, a beautiful drone shot by the way, RAM use quickly goes up to the limit. And there's just a single shot in this project. Alright, so buckle up for some memory magic and have a look in the preferences. In Group Image Cache, there's a new option called Don't Load Compressed Data into Memory. Let's see what it does being activated. For a better demonstration, clear the image cache. Everything empty, Then import the buffer compression file. Seems to be a bit faster than before. Boom! The previous 20% memory usage were reduced to an incredible 0.01%. But wait, how about the playback speed? Glad you asked. It's exactly the same as before. Everything's running with the same frame rate. Magic! One note here. For this incredible speed, it is recommended to read the compression file from a fast local SSD to ensure it can provide the reading speed to load footage in real time. But with this technique, it is possible to track extremely long, theoretically indefinitely long sequences. In release 6, beta 1, the object point group Z distance tool was updated with a small but significant feature. Here, we have a shot with a fixed camera and moving object. With the already existing tool, we easily can determine the distance curve from camera to object point group and modify it, like eliminating jitters and other errors. It was very helpful in many occasions since it was introduced. The point used for determining the distance was always the point group's origin or center of mass. This limitation is gone, and from now on it's possible to set a specific 3D point as a distance target. A quick demo how to use it, and why this is extremely helpful. Launch script object point group Z distance tool as a pane in this demo. Okay, at first glance it's the well-known tool. In menu options we find different pivot types. The point group's origin, center of mass, and brand new, a specifically defined point. Simply select an existing 3D point and set it as the pivot. This is extremely helpful to determine the exact depth curve, for example to a neck, when the task is to solve a head object track and the actor's head should be replaced with something. Now, it's very easy to check the distance curve for jitters or spikes and fix this directly in 3DEqualizer4 before exporting. With a brand new Python GUI Editor, it is easier than ever before to create great interfaces for Python scripts, making it incredibly simple to enter the world of Python in 3DE4. This tool can be found in menu Python. And here comes the twist. It's a Python script as well. Building Python scripts with a Python script. Okay, less jokes. Launch the script and two new windows appear. The left one is the editor itself, and the right one is a preview window. The interface here is quite simple. With the editor we create widgets and edit their properties with all the parameters we can see here. The preview window shows how the script window will look like. Alright, time for a demo. We will build a very simple UI containing a text area and a button beneath it. Both widgets should react to requester boundaries and each other, therefore their size being dynamic. Sounds complicated? It's not. Actually, we just need a few minutes for it. Add a list widget by selecting Edit, Add, Text Area Widget. All widgets that are being used in 3D4 are available here, including creating menus. Okay, the widget appears in the widget list and in preview window. A widget can be selected in two different ways, either left-clicking on it in the list or left-clicking as well directly on the widget in preview window. Yes, the preview window is basically an editor as well, allowing positioning and defining constraints, but we will get to this in a bit. Give it an appropriate name and a label. Now have a closer look at all the parameters here. We can define a size, for example. Let's make it a bit bigger. As well as the position within the requester, with the 4 attached parameters. Positioning a widget is really easy. Simply drag it around by holding the middle mouse button. We notice there are 2 white lines at the top and left side. These lines show the attachment of the text area widget. By default, a new widget is attached to the window's edge at its top and left side, which is also shown in the editor window. Attachment modes of attached left and attached top is set to attach window. Each side has options how and to what it should be attached. Beside attach window, more options are attaching it to the exact opposite window side or another widget. Here we leave it like this. Just place it a little bit away from the window edge so its label is still visible. For a little more precise placement, text field offset is very useful to enter exact pixel distance values. Nice, we successfully positioned our first widget. Easy as pie, right? Just to conclude all parameters found here. Of course we can set an individual color, like giving it a nice font color. Last, make it editable, so the user can enter custom text. Great. Obviously, we would like to check if everything is working so far, meaning how will the user see and experience this UI? First, we need to change the preview windows mode by opening menu Mode. By default, it's set to Edit, so we can edit all widgets directly within this window. Switching to Play mode will disable all editing functionalities, but displays how widgets behave in reality. We can enter an individual text, for example, or we check the attachments. Independently from the window size, the text area stays at the exact same position. Exactly what we defined. But initially, there was some talking about a dynamic size. This is what we're doing next. Therefore, we have a closer look at the other attachment modes for the widget's right side. Switch back to Edit mode. Again, we have two ways of attaching a widget to a window or another widget. First, as we already know, by selecting the specific mode in the editor. The second way is in Preview window. Now this is cool. When we like to attach the widget's right side to the right window edge, simply right-click and hold it within the right half of the widget. Then, click-drag the appearing white line near the window's edge. That's it. The correct attachment mode was set automatically. Awesome. Reduce the offset value a bit so it gets closer to the edge. Nice. From now on, the widget has a dynamic size. By the way, we can check this in Edit mode as well. Simply rescale the window. And here we go. The widget always stays 30 pixels away from the window's edge. So, we're done with the text area. It's time for the button. Edit by selecting Edit, Add Button widget. A new item appears in List and Preview window. Quickly drag it beneath the text area. We see again the default attachment at its top and left side. Good. Change name and label to something more appropriate. Next, a more precise positioning. Since it should be beneath the text area, it makes sense to set an attachment at its right and bottom side. Let's do this. Right-click again on the widget, then release the mouse button near the window's edge. Please note, it is not necessary to drag it close to the edge. Just release the mouse button somewhere near an empty area, meaning not on another widget. What happens when doing this will be shown in the next step. But first, to not stress the OCDs among us, let's enter some precise offset values matching with the text area. Okay, we have defined the button should be placed with a fixed distance to the right and bottom side of the window, resulting in a way too big button. This happened since it has attachment constraints to all four edges. So, delete the attachment constraints for left and top side by setting their modes to Attach None. The white lines disappeared, and it has the size of a usual 3D button. Now, when we rescale again the window, the button moves accordingly, but also slips underneath the text area. Well, that's something to be fixed. Or leave it like this if you like to annoy some users. Not saying this wouldn't be fun, but in the end we would like to have a working script making everyone's life a bit easier, right? To prevent the button from wandering into this not so user-friendly zone, a fixed margin between text area and button seems like a good idea. So, create a constraint between both widgets. Simply attach the text field's bottom side to the button. Again, having the text area widget selected, click-drag with the right mouse button and release it upon the button. A white line between both widgets appear, and parameter attach bottom was set to attach widget, also stating the current distance value and to which widget the bottom side is attached. Reduce the offset value a bit. Perfect. Have a final check in Play mode. Awesome, no overlapping anymore, and both widgets react dynamically to the requester window size. Incredible how fast we can build an UI. That's it, with all the basic editing features of 3DEqualizer4's Python GUI Editor. Last step is saving the project, and then exporting the script. The GUI editor works independently from a 3DE project file, therefore is saved into a separate file. Okay, now export it as a Python file, so the world can enjoy this masterpiece of programming. We have three options for exporting a script. Plain script, just to get the UI code, so it can be implemented in an existing script. For example, export script as a template, and update an existing script to update scripts that were exported here as a template. So let's export our little masterpiece as a template. This option basically exports an entire Python script for instant use within 3DE4, more or less. The functions for all widgets still have to be coded, but we get a complete UI code and config code lines for placement in 3DE4. Using this option provides further options to define all parameters of the comment section within a Python script for 3DE4. Name, exact placement within 3D's UI, and a comment. Those who have already looked into a 3DE script file have seen these comments. Okay, this script should appear in the main window, in its own menu, and be able to add it as a pane to display area. Export it directly to 3DE's Python folder. Close all windows, and here we go. The script was automatically added to the UI. No rescanning or reloading, it's already there. That's such a fantastic feature and will be exciting to help all users, giving them a tool to easier engage with Python scripting. Release 6 Beta 1 introduces a popular request by its users: import-export of Alembic files. Let's have a quick look at it and how it works. First, import a scene from an Alembic file. By selecting 3DE4, File, Import, Import Alembic. A new window appears, just containing some buttons at top and bottom, a text field, and a list widget. It's all we need. Okay, with button Browse, we can import an Alembic file. Nice. The list widget is now filled with items, hierarchically grouped. Let's expand some items. This file format is excellent for importing mostly 3D data. So here we find a camera with animation data, object point groups, 3D points, and also 3D models. And all of this will be imported. The first thing to notice is some items are gray and some are yellow. All yellow entries are suitable for being imported into 3DE4. So, how to import an item? Very simple. Just select them and hit button Import. At first, import a camera. So, select it, then click Import. That's it. Please be aware, the selected camera in the import requester always replaces the current camera in Object Browser. So, if the existing camera in 3DE4 should be kept, create a new one beforehand and make sure it's the current camera. Or have a quick look at the options. Here, we can change some import behaviors, like replacing tracking points with the same name within Point Browser, or if a camera and lens always should be newly created or replaced. Alright, we have a camera from the Alembic file, as we can see, with the same 232 frames. Just a wild guess. The footage should be black. Unfortunately, when standardizing Alembic files, no one thought about something like footage infos. File path, for example. So here, this has to be done manually. A little hint already at this point, there might be a little surprise with 3DE4's own approach to create Alembic files. Nice. Have a quick look at the shot. A lady is walking forward, holding a prop, in a nice fall landscape. Next, import tracking points. We have two types of point groups, a camera and an object point group. Please always have a look at types and names so no points accidentally land in the wrong point group. Like done with the camera, select a point, then click Import. The point was transferred to the camera point group and appears in Point Browser. Note, this is a true 3D point and doesn't contain 2D tracking data, as viewable in 3D orientation controls. Also a missing feature of a standard Alembic file. Here we can perfectly see the solved camera and its path as well. Cool. Alright, on to the next points. Of course, we don't have to import each point individually. Select all remaining points for this point group and click button Import. Nice. We might notice that unlike the camera point group, both groups for object point groups are yellow, so they can be imported as a point group object. Since this point group has a point also named P01, importing the point the same way as previously would just replace it in Point Browser. Also something that can be changed in options, but it's way better to create a new object point group. Or import point group and its point with a single click and create a new point group simultaneously. Select all items, then click Import. A new point group was created in Object Browser, along with its translations and rotations as seen in 3D space. That's awesome. Okay, do the same for the second object point group. Good. Well, there are some remaining items available for import. We know the procedure, so bring them into 3DE4. By the way, polymeshes in Alembic will be imported here as 3D models. Wow, there are a lot of elements, including the 2 3D models. Have a look at them in lineup controls. Works great! We imported everything that is possible and got a working 3D project basically within seconds. Just select all objects and click button Import. To finish this chapter, we need some good stuff to export. Maybe this one with tracking data, 2 point groups, calculated distortion. Excellent. To export, select 3DE4, Export Project, Alembic. A new requester appears. Have a look at the bottom options. Here, we can decide what to include in the export file. Beside 3D models, 2D tracking data, footage information and specifically lens distortion aren't part of the standard Alembic file format. So, 3DE4 utilizes clever ways of using metadata to store them in such a file anyway. Well, it's a fantastic piece of software. Now it's up to other developers to modify import scripts to read these informations. Select a path and file name. Alright, export the project. Then create a new one for importing the file again. Select Browse. Then the recently exported Alembic file. Expand all. Select all. Import. Nice. Looks like before. And the best thing is, since this is a 3DE4 Alembic file, it contains all footage information, 2D points, 3D models, and yes, even lens distortion. A final look in lineup controls. Awesome. That's the 3DE4 way. It just works. It's been a wild feature journey so far, but we're nearly at the end. The last great thing to show today is export lens distortion to Flame. We have a nice project for it, an anamorphic shot with intense distortion. So, to export it, simply select 3DE4, File, Export, Export Flame Lens Distortion. A simple requester opens, only offering the options of setting a file name and overscan values. Set a file name and path. Then click OK. A quick summary of all the files belonging to the export. And that's it. Let's switch to Flame. Here, the sequence was already imported and is waiting for distortion information. Click on Load, Load and Append, and select the recently exported batch file. 4 new items were created within Flame, all necessary for applying undistortion and also redistorting. Append the footage to the nodes. Have a look at the 4 nodes. Here we can see clearly that the correct distortion from 3DE4 is applied. Looks great! These distortion nodes were realized with a GPU shader, so it's not necessary to import giant ST maps. Great for performance and memory space. to have an additional check, insert a checkerboard between un- and redistort node to show the effect with embedded CGI. Perfect. Everything as it should be. Each node provides some additional options found in the bottom menu set. Have a closer look at Page 2 Modes. Here, it is possible to set whether this node should distort or undistort the connected footage. That's it, mates! 3DE4 Release 6 Beta 1 is shipping with a lot of exciting new features and tools. GUI Editor, all updates to 3DE4 UI, memory optimization, a new distortion model, SXR stereo support, foreground masks, flame and Alembic support, just to name a few new features making the 3D experience better and easier. And that's not everything. There's a lot more coming in future Release 6 updates, so stay tuned! At this time also a big shout out and thanks to all users of this extraordinary vibrant community providing feedback. This is a tremendous help to the development. Science Divisions is always listening to you. So, thanks and bye. See you soon.